Hey everybody, how you doing? We have finished up our 3 days of graphing rational functions, and today and tomorrow we're going to spend the next couple days on doing story problems using rational equations. Now there is a worksheet that I'm going to be working out that I'm pulling my examples from, and these examples are right here. These are the 5 examples I'm going to do. Feel free to pause the video. There's a copy of this on my website, but if you just, so you can get all the problems that way, your choice. But you can either take a quick screenshot of these 5 problems, and you have the questions that way. You can find it on my website, you can print it out, you can get the questions that way. Anyway, these are the questions that I am going to try to solve. I'm not going to try to solve them. I am going to solve them. Elliot. Now, number 1, about Sam. Hey, Sam. I'm going to do that one in class on Thursday to kind of set the scene. And then I'm going to do 2, 3, 4, and 5 right now during this video lesson. So take a minute, read number 2. Basketball team, how topical being March Madness. Their team record right now is 42 wins, 36 losses. How many consecutive games must it win so that its winning record reaches 60%? Okay. I'm going to use, for notebook purposes, your notebook needs to have at least 3 of these examples if you want full credit in your notebook for these story problems. So there's a total of 5 examples. Make sure you get at least 3 of them into your notebook. All right, so let's see, can I work it like this? I'm going to fold over this top part to give me a little bit more room. There we go. Okay. All right. Basketball team's present record is 42 wins and 36 losses. Okay, so when I solve these equations, there's always something that you do before and there's something that you do after. And in the before, in this situation, you had 42 wins plus 36 losses, and that was a total of 78 games. So you had 42 wins plus 36 losses. It tells you your total number of games. Okay, well then afterwards, you're going to go on a winning streak. Yeah, winning, but we don't know how many wins you're going to have. So we're going to have X be the number of consecutive wins. And if we keep winning, 42 plus X will be our number of wins then. Plus, well, if it's a winning streak, you'll stay at 36 losses. And then your total would be, well, the 78 games that you had played plus the number of games that you began winning with. So we had a before situation, our after situation, and it says here we want the winning record to reach 60%. So our winning record is the number of wins divided by the total number of games. And we're based off the after because we want to know what's happening after the winning streak. So we want 42 plus X divided by 78 plus X. That'll give us our winning percentage, and we want it to reach 60%, which is a decimal is 0.6. Okay, so these are all going to be calculator problems to solve out. The first thing I would do to solve this equation is I'd multiply both sides by 78 plus X to eliminate the fraction. And over here, the 78 plus x's will cancel out, leaving you with 42 plus x. On the other side, 0.6 times 78 is 46.8, plus 0.6 times x is 0.6x. Then you do a little math magic here, algebra. If I bring over the 0.6x, I'd have a 0.4x. If I subtract the 42 from both sides, minus 42, I'm having a hard time with my math right now, 6.8. And divide that, so I have 6.8 divided by 0.4. That gave me 17. So that means that if you win exactly 17 wins, that would get you to reach 60% winning percentage. Now, what if it said reaches above 60%? Well, then you'd need to say 18 wins, because 17 wins only got you to 60%. But because it says reaches 60%, that's exactly what we want. All right, that's number 2. I'm going to solve every problem exactly like this. So, yeah, just so you know, I'm going to do every problem just like I just solved number 2 here. So if you understood this process, maybe you could kind of try out some of the other problems on your own. All right, next problem, number 3. Take a minute and read number 3. Ooh, it's about milk. Awesome. Hey, if you drink milk, this could be considered a real-life math question for you. All right, so you have 2% milk, but let's say you don't want 2% milk. What if you wanted whole milk? So technically, all that has is it has a higher percentage of fat. Instead of 2% of fat, whole milk is apparently 3.25% of fat. So if you wanted to get whole milk, you'd really only need to add pure fat to get to that whole milk. Sounds gross, and I wouldn't recommend it, but you could. Now, just like before, I'm going to do a before and an after equation, and I'm going to use the after equation to write my final equation. 2% is fat. So that means that it's 2 gallons, that 2% is fat. So that means that of the 2 gallons, 0.02, 2% is fat, which means the rest of it is not fat. So in this case, it would be 2 times 0. Well, if 2% is fat, that means 98% is not fat. Not that, 98%. So this would be 0.98. And if you work this out, 2 times 0.02 is 0.04. 2 times 0.98 is 1.96. And if you add the two of them up, you'd get the 2 gallons that you had. Now, we are going to add how much pure fat. So, so that's going to be X is amount of fat. So 0.04 plus 1.96, that was equal to 2. But I'm going to take this 0.04 and I'm going to add pure fat to it. Oh, but wait, it's 2 times, oh, Elliot's getting mildly confused. So it's 2, so we have this. So it'd be 0.04 plus X, so we're going to add the fat to the fat mixture of it, plus this 1.96 is equal to 2 plus X. So this is the amount of fat and then this is the total. And in this one, so how much pure fat would be added? So we want the 0.04 plus x divided by 2 plus x to be equal to, we want 3.25% of fat, so we want the fat divided by the total to be 0.0325. Alright, setting these up is the hard part. Once you have that, these always have the exact same process to solve them out. You would first want to eliminate the fraction by multiplying both sides by the denominator here, 2 plus x. You get that canceling out, and you get 0.04 plus x equals 0.0325 times 2. That's 0.0650 plus 0.0325x. If I brought all the x's to one side, all the numbers to the other, 1x minus 0.0325x is 0.9675x. The other side, 0.0650 minus 0.04 is equal to 0.025. I'm making a video lesson right now. Yeah, just do what you need to do. Oh, that means the last person didn't put it away correctly. Alright, last step. We're going to divide both sides by this 0.9675. So 0.025 divided by 0.9675 is, x was 0.0258. Now, the next number after that's 3. Now, if I add 0.0258397, like if I add, like this is what my calculator tells me. So if I add this much, it will get, and if this decimal went on forever, that would give me exactly this 3.25% milk. But if I only answer 0.258, actually, I normally ask for 3 decimal spots. If I answer 0.025, technically you wouldn't be at 3.25% yet. You'd be just below it because you need that extra 8 there to get to that whole milk version. So in this case, I'm going to answer 0.02. These problems are usually on an auto round up type situation because 2.5 you wouldn't quite be there. So you round up to 2.6 so that it is. And then way back at the beginning I said amount of fat, and we were doing all of this problem in gallons. So this is a really small number, but when you think about it in terms of gallons, it's not that small. But it's 0.026 gallons. It's actually still pretty small. Anyway, that's that problem there. Okay, let's take a look at number 4. Read through number 4. 2 gallon whole milk. So we still have whole milk. Oh, we have whole milk this time, but we want it to get down to 1%. So this one's going to be a little bit different because we are removing stuff to get there. So this is number 4. So I still have my before. My before, it's whole milk. So there's going to be fat and there's going to be not fat. Now of the 2 gallons, 3.25% is fat. So let's start over. This is the fat part. So 2 times 0.0325 for the whole milk, plus 2 times, well, if 3.25% is fat, that means 96.75 is not fat. So 0.9675 is not fat. and I'm going to test that to make sure I did my math right. 0.0325 plus 0.9675 should add up to 1. And it did. So I know that I got these two right. But if you go 3% of a number plus the 96% of another number, and you're multiplying it by that base number, you end up with this too. So the total amount of fat is 0.0650, and the total of not fat is 1.9350. And these two numbers should add up to the 2 gallons of milk that you have, fat plus not fat. I'm just going to check that out. 0.0650 plus 1.935. Oops. Start over, Elliot. 0.065 plus 1.935 gives me 2. Boop. Okay, so that's what's happening before. Then after, in this case, we are going to remove fat. You ever wonder how they do that with milk? I do. They get the milk, it's full of fat and other ingredients, then they remove a bunch. How do they get rid of it? It's something we probably learned on Sesame Street at some point. But in this case, we're removing. So we're going to take that amount that's fat, and because we're removing it, we're going to subtract x, and that's the fat, plus the non-fat. The not fat is that 1.935, and that's going to be equal to the 2 gallons minus the amount of fat that you just removed. So ultimately in our equation, way down here, oh, I didn't write x. What is x? X is the amount of fat removed, and we are measuring this in gallons again. So I have 0.065 minus x, which is the after, divided by the 2 gallons minus the amount of fat that you removed, and we want it to get to 1%, so 0.01. Then once you have your setup, you always solve them out the exact same way. First, get rid of the fractions by multiplying both sides by your denominator, 2 minus x. On the left side, the 2 minus x's cancel out, and you're left with 0.065 minus x. On this side, 0.01 times 2, that's a doubler, 0.02 minus 0.01x. All right. In this case, I'm going to bring all the numbers to the right, making this 0.0. If I subtracted this from both sides, it would become 5. On the other side, if I added this to both sides, negative 0.01x plus 1x would then be 0.99x. And then you divide both sides by the 0.99. And 0.045 divided by 0.99 is 0.0454545. The 45 is repeating. So we got to think about this. As you are removing milk, as you get to this exact number, you have achieved 1%. But if you needed to round your answer to 3 decimal spots, 0.045, if you removed that much, you need to remove that much more to get up to 1%. So technically, if you do 0.045, you'd still be a little bit above that 1% that we wanted the milk to be. In which case, this is a problem that you also need to do an auto round up. If you do 0.45, that's not quite enough to get up to that 1%. So this is one that you'd have to round up to 0.046 gallons. So you don't always have an auto round up. Sometimes it's an auto round down. But so far, the 2 problems that we've looked at, that had rounding were both auto round up. Let's read number 5. It's about gold, and let's find out how gold works into this. Pure gold, too soft. So gold is always mixed with other minerals. 18% 18 karat gold is 75% gold, 25% other metals. How much pure gold must be mixed with 5 ounces of an 18 karat gold to make a 22 karat gold, which is 91.7%. Okay, so before, you had 5 ounces and it's 18 karat gold, so it's 75% gold plus not gold. So of those 5 ounces, 0.75 is gold, and of those 5 ounces, 25% of it is not gold, and that will add up to 5. And maybe do a little bit of math. 5 times 75% is 3.75, which would make this 1.25. So I have 3.75 ounces of gold and 1.25 ounces that's not gold, which adds up to the 5 ounces of 18 karat gold. Then, what I'm going to do afterwards is I'm going to add pure gold to the mix. So I'm going to take this part that's pure gold, the 3.75, and I'm going to add some more gold to it. I'm not going to add any not gold, so that's just going to stay 1.25, and then I would have those 5 ounces plus the amount of gold that's going to be added again. So that makes X the amount of gold. What are you doing to that gold? You're adding it. So gold added. And how are we measuring this gold? Ounces. So I know that I have, if I want to figure out how much to get it to be 91.7%, that's the after. So it's 3.75 plus the amount of gold would be divided by the total number plus the amount of gold, and that must give us 91.7%, so 0.917. 91.7%. All right, that's the setup. And once you're done with the setup, you then you multiply both sides by the denominator to eliminate the fraction. Don't forget to use parentheses when you do that. The 5 plus x's cancel out on the left, and you're left with 3.75 plus x. On the other side, 5 times 0.917 is 4.585 plus 0.917x. Do a little bit of algebra. On the right side, I have 4.585 minus 3.75, and that's 3.835. On the other side, I have 0.083. What happened to the x? The x is right here. And if I divide both sides by 0.083, there's going to be a big number. 3.835. Oops, start over. 3.835. Start over. 3.835. Calculators, they get you sometimes, huh? Divided by 0.083 gave me an answer of 46.204819. And once again, let's say that we had to answer to the 3 decimal spots. If you stopped at 46.204, knowing that there's this 819 still on the decimal, if you only added 0.204, that will not be enough to get you up to that 91.7% gold mixture for that 22%, to where 22 karat that is. So this is another one that no matter what, you have to round up. So our answer is actually 46.205 grams. And that should be enough to get you up to 91%. Whew. All right, everybody. That was a long lesson, and I hope it worked out for you. If you have any questions, hopefully you stopped along the way and asked them. And like I said, for notebook purposes, make sure you have at least 3 of these 5 story problems in your notebook. Have yourselves a great day. Bye-bye.